Hello everyone, welcome to Vedantu Malayalam channel. How are you guys doing? Hi everybody, and good evening to all of you. Welcome back to Relations and Functions, that is chapter number 1 of our plus 2 Limitless series. Well, today is the last lecture of this chapter, that is lecture number 5, and today we are going to learn about binary functions. Well, this is a topic that used to be very difficult for the students. So what CBSE did, they basically deleted this topic from NCERT this year. So if your school follows NCERT and if you are somebody from CBSE board, then definitely this is not going to come in your board exam, but it is going to come in your competitive exams definitely. Be it KEAM exam, CUET exam, JEE exam, in every exam this concept is going to come because it is the toughest. So basically, we have to learn about it, and that's why we are here with binary functions complete lecture. All right. So if you are somebody new on the channel, don't forget to subscribe to it. I am Sana Khan, your mathematics master teacher, and I will be taking maths on this channel for plus 1 and plus 2. Okay. We also have physics, chemistry, and biology teachers. Well, I know that you might be thinking that ma'am is not speaking in Malayalam, she's talking in English. How we will learn? Well, you will learn it very easily. You don't have to learn English now. You are here for learning mathematics. And mathematics is like, you don't need language for that, right? So yeah, do subscribe to our channel, and if you enjoyed today's video, hit the like button. It gives us lots of motivation, and share this video with your friends so that they can also have some benefits, right? So yeah, today we will learn binary functions. Before this, we have already learned and seen introduction of relations and functions. We have seen the different types of relation, different types of functions, composition and inverse of function, and binary function will be completed today. And after this, whole chapter is done, right? Now, on our community page, I pasted a poll asking you guys which chapter you want to study next. So, maximum students have said they want to study continuity and differentiability concept, right? So, from Monday, we are starting this chapter. Most probably, Monday, 5 p.m., we are starting this chapter. Monday is confirmed, timing is not yet confirmed, but it will be confirmed to you on community page, don't worry. So next chapter will be continuity and differentiability on your demand. So yeah, I hope you're happy with that. So now let's start today's lecture with binary functions. Okay, so to understand binary functions, we need to understand binary operations, or what are binary operations and how do we apply it on functions. Let's learn about them in detail. So starting the class with a quick high five to you guys, and let's begin with full on Josh. Now, what does binary mean? Have you heard of this term? If you are somebody who has taken computer science in class 10th or in 11th and 12th, so you know what binary means. It basically means two, right? So any operation that is happening between two things, two numbers, two alphabets, two variables, is called as a binary operation. For example, suppose you have a set X. Okay, now in this set X, you have some elements. Suppose you have 1, 2, 3, 4, 5. Okay. And you take two elements of this set. Either you add them, or you subtract them, or you multiply them, or you write them as powers. You are doing basically an operation between two numbers. Such type of operations are called as binary operations. And how we denote them? So a binary operation star on a set A is basically a function. It's not just addition, subtraction, multiplication, division. It's a function applied on the cross product applied on the ordered pair A cross A, where we get one single number as the output, one single function as the output. Okay, we don't get ordered pair as the output. Obviously, if you do 2 plus 3, you will get 5. You will get a single number. If you do 2 to the power 3, you will get 8, a single number. You are not going to get an ordered pair. So a binary operation star on a set A is applied on an ordered pair, but you get a function as the output. So we denote star on an ordered pair AB as A star B. Okay, so what is star? Star can be anything. It can be plus, it can be minus, it can be divide, it can be a to the power b, it can be a square plus b square. The function can be anything, the operation can be anything. It is just denoted with the help of a star to denote that it is binary operation. Okay. Now one thing, did you observe? An operation is said to be binary if the operation is applied on a set and the answer also belongs to the same set. Did you guys understand that? When you are applying the operation on A cross A set, the answer is also belonging to set A. It cannot go beyond set A. What does that mean? Let's look at a simple example. Suppose they ask you, show that addition is a binary operation on natural numbers. What does that mean? Simple. Suppose I have a set n which contains all the natural numbers 1, 2, 3, 4 and so on till infinity. All the natural numbers are there. Now, I am doing an operation, a binary operation A star B, where the binary operation is basically addition. So I am doing A plus B. Now I want to know A plus B belongs to natural number or not. Take any example. 2 plus 3 is 5. 5 belongs to natural number. 1 plus 7 is 8. 8 belongs to natural number. Any number. 100 plus 2 is 102. It belongs to natural number. So my output belongs to natural number set. That means what? That means I can say that addition is a binary operation on natural numbers. Okay. So if I do addition of natural numbers, I will get a natural number. That is the meaning of binary operation. Similarly, is subtraction and division a binary operation on natural numbers? Let's check. Natural numbers include 1, 2, 3, 4 and so on till infinity. Now suppose I am doing subtraction of two natural number. I take ordered pair 3 and 5. 3 minus 5 is minus 2. Minus 2 does not belong to natural number. Minus 2 is an integer. It is not a natural number. So I will say that subtraction is not a binary operation on natural number. Okay. Subtraction is not a binary operation on natural number because output is not a natural number. Is it clear to all of you? Similarly for division, if I take two natural numbers 3 and 5, 3 divided by 5, is it a natural number? No, it is not a natural number. It's a fractional number. It's a decimal number. And therefore, division is not a binary operation on natural numbers. So everybody understood? How can we say that it is a binary operation or not? So if you are doing a binary operation, so binary operation input is A cross A, output should belong to A. Okay, or I should write it like this. Input belongs to A cross A, output belongs to A. Then only it is called as binary operation. Okay, let's see some more examples. Show that star is a binary operation on the set real numbers. So R cross R, output is also real number. You have to prove it. Simple. Now if I take two ordered pairs, so solution will say let A comma B belongs to R cross R. I am taking an ordered pair that belongs to the cross product R cross R. Now A plus 4B square is what? You are taking two real numbers, squaring them, adding them. Will it be a real number? A plus 4B square will belong to a real number? Yes. A plus 4B square belongs to real number set. Therefore, star is a binary operation. It is a binary operation. Why? Because if I take example, if I take ordered pair 3 comma 2 belonging to real numbers, then 3 plus 4 into 2 square is 3 plus 4 into 4. 4 4 is 16, 16 plus 3 19. 19 belongs to real numbers. You know, 19 belongs to the real number. So it is a binary operation because my answer is also a real number. Clear? The input belongs to R cross R. The output should belong to real number. The same set. Okay. Alright, now moving on to the properties of binary operations. Okay, property number 1. First property says that a binary operation star on a set X is said to be commutative if A star B is equal to B star A for all AB belonging to X. Similarly, a binary operation star on the set A cross A to A is said to be associative if bracket A star B star C is equal to A star bracket B star C. That means the brackets are changing, the groupings are changing for all ABC belonging to set A. Then we say that it is associative. Let's solve some examples and understand it better. First question. Show that star operation on real numbers defined as A star B is A plus 2B. Show that it is not commutative. How? Let's take an example. Suppose A is 3 and B is 4. So, A star B is 3 star 4. 3 star 4 is what? 3 plus 2B is coming 11. 4 star 3 is 4 plus 2 into 3. 4 plus 6, 10. 10 is not equal to 11. So left hand side is not equal to right hand side. It is not commutative. Understood? It's not commutative because A star B is not equal to B star A. Understood? Similarly, let's do one more example. Determine whether a binary a star, determine whether the following star is binary, is commutative or associative. It is defined on positive integers defined as A star B is equal to 2 to the power AB. Now, first question. Is it binary operation? Is it a binary operation? Let's check. Example, A is equal to 3, B is equal to 4. A star B is 2 to the power AB. So, 3 star 4 is 2 to the power 3 into 4, 2 to the power 12. 2 to the power 12 belongs to positive real number. So, we say that yes, star is a binary operation. This is first proof. Second, is it commutative and associative? Let's check. To check commutativity, to check commutativity. Is it commutative or not? Simple. A star B should be equal to B star A. Okay. So 3 star 4 should be equal to 4 star 3. What is 3 star 4? 2 to the power 3 into 4. 4 star 3, 2 to the power 4 into 3. This is 2 to the power 12. 4 3s are 12. LHS equals to RHS. Hence, commutative. Hence proved that it is commutative. है ना? We have proved that it is commutative. Why? Because A star B is equal to B star A. So it is commutative. Now let us check it is associative or not. Okay. To check associativity. Okay. A star B star C should be equal to A star B star C. Now what is B star C? It is A. No. We will not take A, B, C. We will take some numbers. So let A is equal to 3, B is equal to 4, C is equal to 5. Let's take that example. Okay. So here we have 3 star 4 star 5, 3 star 4 star 5. So first we will open this bracket. So it will become 3 star. What is 4 star 5? It is 2 to the power 4 into 5. Here we have 2 to the power 3 into 4 star 5. Now the question becomes, what is 3 star 2 to the power 20? So it becomes 3 star 2 to the power 20. It becomes 2 to the power 12 star 5. So it is again A star B. A star B is what? 2 to the power AB. So this becomes 2 to the power 3 into 2 to the power 20. This becomes 2 to the power 5 into 2 to the power 12. Are they equal? No. Left hand side is not equal to the right hand side. है ना? 3 into 2 to the power 20. 5 into 2 to the power 12. 3 into 2 to the power 20 is not equal to 5 into 2 to the power 12. Therefore, left hand side is not equal to right hand side. Therefore, not associative. It is not an associative binary operation. It is binary, it is commutative, but it is not associative. Clear? Okay, next question. Star is defined on the set 1, 2, 3, 4, 5. A star B is basically HCF of A and B, highest common factor of A and B. Is it commutative? Justify your answer. Simple. How to check commutativity? A star B is equal to B star A. So, let's take an example. A star B should be equal to B star A. So, highest common factor of, let's take example of 3 and 4. Highest common factor of 3 and 4 should be equal to highest common factor of 4 and 3. What is the highest common factor of 3 and 4? Tell me. Tell me quickly in the chat box. What is the highest common factor of 3 and 4? Common factor means a number that can divide both of them. So what is the highest common factor? 1. What is the highest common factor of 4 and 3? 1. So LHS is equal to RHS. Therefore, star is commutative. We have proved with an example. You want to take any other example? You take any other example. What is the highest common factor of 4 and 5? 1. 5 and 4? 1. Again commutative. So take any two numbers as an example. Check that is A star B is equal to B star A. If yes, it is commutative. Okay. Moving on to third and the fourth property. Third property says that given a binary operation star on the set A cross A to A, an element E belonging to set A exist and is called as the identity for the operation star if A star E is equal to E star A is equal to A itself. That if you apply operation between A and E, you will get A as the answer. Then you call it as an identity of the binary operation. Okay. Similarly, if you have an identity in the binary operation for an element A belonging to set A, it is said to be invertible with respect to the binary operation if there exists an element B such that A star B is equal to identity element. It is like multiplicative inverse. We have learned now that a number is said to be reciprocal if number into reciprocal is equal to 1 because 1 is the identity element of multiplication. So similarly here, if A star B is equal to E, then B is basically inverse of A. Okay? Inverse of A. Understood, everybody? So these are the two more properties of binary operation, and that's all. So in binary operation, only this much of syllabus is there. What is binary operation? Their commutativity, associativity, their identity element and inverse element. Okay, let's solve some questions and understand it better. Question number 1. Consider a binary operation star on natural numbers defined as A star B is A cube plus B cube. Choose the correct answer. Is it associative, commutative? Commutative but not associative. Associative but not commutative. Let's check. Okay. First, is it commutative or not? How will you check? A star B should be equal to B star A. What is A star B? A cube plus B cube. What is B star A? B cube plus A cube. Are they equal? Yes, of course. 3 cube plus 2 cube will be equal to 2 cube plus 3 cube, right? 8 plus 27 and 27 plus 8 are same. So is it commutative? Yes. So yes, it is commutative. Okay. Second, to check associative or not, what do we have to check? A star bracket B star C is equal to A star B bracket star C. Let's apply the operation. So it is A star B cube plus C cube should be equal to A cube plus B cube star C. Now again you have to apply the star, the binary operation. On what? On these two numbers now. So now when you apply the binary operation, you get first number cube plus second number cube. Now what is my second number? My second number is now B cube plus C cube whole cube. Okay. Now here it becomes A cube plus B cube whole cube plus C cube. Are they equal? No, left hand side is not equal to right hand side. So what is the right answer? The right answer is it is commutative but it is not associative. Okay, it is commutative because A star B is equal to B star A, but it is not associative because this is false. Okay. Next question. Let star be a binary operation on the set of rational numbers. Which of the following operations given below has an identity element? Let's check. Okay. A minus B. Subtraction has identity element. Is it possible that when you subtract a number from rational numbers, you get the same number? Is it possible in any situation? No, it's not possible. Okay. So, A minus E will not be equal to A for all E belonging to rational numbers. Next, what about A square plus B square? A square plus E square cannot be equal to A for all E belonging to rational numbers. Next, A square plus A into E. Can this be equal to A? Of course not. A square, how will it become A? For all E belongings to rational numbers. Last option, AB by 4. Is there any value? Yes. Which value? A into E upon 4 is equal to A when E is equal to 4, right? So, for option number D, A star B is equal to AB by 4 has identity element E equals to 4 because A star 4 is A into 4 upon 4 is equal to A. A star 4 is A, therefore 4 is the identity element. So option D is the right answer, that this binary operation has an identity element. Okay. Next, let star be a binary operation on the natural numbers given by A star B is LCM of A and B. Find that it is commutative, associative, or find the identity of star in the natural numbers. Let's do that. Is it commutative? Sorry. Let's check. For A, B belonging to natural numbers, LCM of AB, wait, I will write it like this. I want to check commutativity. So A star B should be equal to B star A, right? So lowest common multiple of AB and lowest common multiple of BA should be same. Take any example. Lowest common multiple of 4 and 3. Lowest common multiple of 3 and 4. What is the common multiple of 4 and 3? 12. 3 and 4? 12. Both are same. So, yes, it is commutative. Let's check associativity. A star B star C should be equal to A star B whole star C. That means LCM of, wait, I will write it like this. A star LCM of B and C should be equal to, or we can do one thing. Example. Let's take example. You guys will understand better with an example. Okay. So let me take example. 2 star 3 star 4. 2 star 3 star 4. So 2 star LCM of 3 and 4. LCM of 2 and 3 star 4. Now, what is the LCM of 3 and 4? 12. Lowest common multiple is 12. So 2 star 12. What is the lowest common multiple of 3 and 2? 6. So least LCM of 2 and 3 is 6. So we have 6 star 4. Now 2 star 12 means LCM of 2 and 12. And this means LCM of 6 and 4. What is the LCM of 2 and 12? Lowest common multiple of 2 and 12. It is 12. LCM of 6 and 4. 12. 6 2 is a 12. 4 3 is a 12. So here also left hand side is equal to the right hand side. Therefore the answer is yes. It is associative. It is associative. Lastly, very interesting question. Find the identity of the binary operation of this natural number set. Now, what will be the identity element when you are finding out LCM of A and B? Think about it. So, identity element has to be A star E should be equal to A itself, right? That means LCM of a number with E should be equal to the number itself. When is it possible? Think, what is the LCM? Lowest common multiple of 3 and 1? It is 3. What is the lowest common multiple of 100 and 1? It is 100. Least common multiple of 1 and any number will be the number itself, because 1 is like factor of every number. So that number will definitely be a multiple of 1, right? So LCM of A and E is E when E is equal to 1. Okay. So therefore, E is equal to 1 is the identity element for this star operation in natural numbers. So E is equal to 1 is identity of star in natural numbers, because LCM of a number with 1 is always the number itself. Alright, so this is how you identify it is commutative, is it associative, is it having an identity element. Alright, so guys, that was all about relations and functions chapter. We have completed everything that was there in this chapter for any competitive exam, for any board exam that you are going to give this year. Sorry. So if you have followed this complete series of relations and functions, if you have watched all the 5 lectures, then you don't need to prepare anything else from this chapter. Everything has been covered from starting till end. Okay, so guys, if you want notes of the lectures we do every day, just join our Telegram channel and the notes will be provided to you there itself. Along with the notes, you also get all the notifications, all the extra informations. So after your classes, the only communication possible between us is through Telegram. So do join the Telegram. Simply search for Vedantu Malayalam channel or scan this code. Okay. So thank you for watching today's video. Hope you enjoyed it. If yes, don't forget to subscribe, because if you won't subscribe, you won't get the daily amazing videos coming up for physics, chemistry, maths and biology, +1 and +2, and lots of study tips, exam tips, special announcements, everything that you guys want. Okay, do let me know in the comment section, did you guys enjoy today's lecture? Was it useful for you or not? And yeah, hit on the like button. It gives us lots of motivation from you. So thank you. Leave a comment, share your feedback. We are always welcoming your feedbacks and working on them to improve. Thank you everybody. Hope you enjoyed it. See you in the next class. So tomorrow I am bringing a very interesting video for all the +2 students who are pursuing PCM. So do watch it 8 p.m. Also from Monday we will start continuity and differentiability chapter. So be ready for that. Okay, so see you guys tomorrow. Till then, take care. Bye-bye.